Number 6, when pressure increases, volume blank, why? Okay, so let's take a box here. And in this box, the particles, let's say, are just moving like so. Well, now, suddenly, the pressure is going to increase, which means that the particles will be hitting the wall more. Well, if the particles are hitting the wall more, then that must mean that the container decreased in size. So if this is now the new size of our container, if the particles are suddenly hitting the wall more and there's been no temperature change, that means that the size or the volume of our box has decreased. So when pressure increases, volume decreases. So then, of course, this would be an indirect relationship. And the best explanation here would be as the volume decreases, or excuse me, if the particles are hitting the wall more, the size of the container must have decreased. Picture me in the classroom. If we've got the whole size of the classroom here, remember I often play the role of a particle, it takes me forever to go from one side of the room to bounce off the other and so on. Then if I take a smaller space, like between two of the desks here, and I'm particle here, I'm going to bounce much more frequently. So if the size decreases, the pressure will increase. So as pressure goes up, volume goes down. As pressure goes down, volume goes up. Number 6, draw an example graph of a direct, indirect, and no relationship graphs. Okay, remember for direct, that as one variable goes up, the other goes up. Or as one variable goes down, the other goes down. Indirect is the opposite. As one variable goes up, the other goes down, or as one variable goes down, the other goes up. And a no relationship graph means that there's no relationship between the variables, so the graph will look not like a direct or indirect. So let's draw our direct graph first. Let's say we know an example of a direct relationship is temperature and pressure. So as temperature goes up here along the x-axis, pressure is going to go up on the y, so that would be a direct graph. We know indirect, a good example of that would be pressure and volume. As pressure goes up here, volume goes down, so a good indirect graph would look like this. And finally, a no relationship graph would be like this, because there's no relationship between the x and the y variables. As x increases, y has no change here. Okay, this is now station 3 of your Team Ziggurat. It says, suppose that you lowered the temperature of a gas from 100 C to 50 degrees Celsius. By what factor do you change the volume of the gas? Okay, a lot of students here will say, if we go from 100 to 50, then the volume of the gas will be cut in half because the temperature is cut in half. That's the most common answer. However, keep in mind that this is in Celsius and we need to convert it to Kelvin. So 100 Celsius plus 273 is equal to 373 Kelvin, and 50 plus 273 is equal to 323 Kelvin. Okay, when you're trying to determine your factor, you need to convert to Kelvin. And so let's find the factor of these. So we'll do 373 divided by 323. And when we divide those, 373 divided by 323, we get a factor of 1.15. Now the question is saying we lowered the temperature by this, so by what factor are we going to change the volume? Well, the answer is 1.15. Notice that if you did it with Celsius, you'd get 100 divided by 50, which is equal to 2. This would be incorrect for your factor because you have to convert to Kelvin. And so don't get tricked by this Celsius temperature scale. The factor is going to be 1.15 because you have converted to Kelvin. Question number 2 here. Suppose that 25 milliliters, okay, this is going to be a volume, of a gas at 725 millimeters of mercury, that's going to be a pressure, And 20 degrees Celsius is going to be a temperature. However, in your brain, bells should be going off thinking, oh, I need to convert this to Kelvin. So let's get rid of this and convert 20 plus 273 is 293 Kelvin. Is converted to standard pressure and temperature. What would be the new volume? Okay, let's plug in our values here. 25 milliliters is our initial volume. Our pressure is 725 millimeters of mercury. And our temperature is 293 Kelvin. Well, a lot of students will look at this and say, they did not give me any other information. What do I do? How do I find my final values here? Let's reread the problem. Suppose that 25 milliliters of gas at 725 millimeters of mercury and 293 Kelvin is converted to, oh, here it is, guys, standard pressure and temperature. So this actually, there's a lot of information contained within these words. Standard pressure, of course, means 760 millimeters of mercury, and standard temperature means 273 Kelvin. It's 0 Celsius, which is 273 Kelvin. Okay, well, our standard pressure here, it goes to 760 millimeters of mercury, which of course then is an increase overall in the effect. Our temperature goes to 273 Kelvin, which of course is a decrease. And so we need to find the effect of our volume. Well, the first step here is to look at the factor by which our pressure has changed. 725 divided by 760 is equal to 725. So our factor here is 0.954. It says 0.953947368 on my calculator, but because this value has 3 digits, I will use 3 significant figures here to get 0.954. Okay, now I want to know how this is going to affect my volume. Now I think, okay, if pressure goes up, volume will go down because it's an indirect relationship. And so in order to get this value for volume to go down, I'm going to need to multiply by this factor. So 25.0 times 0.954 equals, so I'm going to multiply by 25 and get 23.8. Now I know I've done this correctly because I was expecting my volume to go down, and sure enough I've got a decreased value for volume. Now that has accounted for the pressure change. The next thing I need to do is account for my temperature change. So let's find the factor here by which temperature decreases. 293 divided by 273, these are in Kelvin. 293 divided by 273 is equal to 1.07. Okay, now I think, oh right, if temperature is decreasing, volume must also be decreasing because it's a direct relationship. So I'm going to use this factor and divide by it to see the decrease in volume. Now the trick here is I don't want to start with this 25. I want to start with the volume that I already know has decreased to 23.8. So I'll take my 23.8 milliliters and divide by 1.07 to get a value 22.2. And so sure enough, I do see a decrease, which is what I was expecting. So my final volume is 22.2 milliliters, which is an overall decrease. So folks, first take your factor for pressure here, find that factor, and you will multiply to see your decrease. Then find your factor for temperature, and you will divide to see your decrease, and you get an overall answer of 22.2 milliliters.